Here we'll take a look at a simpler projectile motion question, which is relatively more numerical and less algebraic. And so we'll basically be doing some calculations with this. So in this question, we have a projectile. It's thrown horizontally from the top of a tower, which is 125 meters high, as they've kind of done here. So you're projecting it with some velocity horizontally with capital V meters per second. It clears a second tower of height 100 meters as drawn by a distance of c as shown, and they're 20 root 5 meters apart. And you're given your equations of motion. So whenever you're given equations of motion in the exam, you don't need to prove that, as the question is going to make it very clear usually over here, do not prove this. So they'll ask you to set up where's the origin. And if we take a look at where we're heading, we want to find v, the speed we're sending it across, relating it to c. You want to prove the minimum initial speed of the projectile to clear it. And then you want to find how far it goes before it lands, and find the vertical component of the velocity of the projectile when it strikes the ground. So none of this is too particularly difficult. And let's just take a look at part one. You want to find the origin of the system, which remember is always up to you where you want to set it, if the question hasn't already decided your equations for you. So basically you just need to think about where x equals 0 and where y equals 0 is. So when x equals 0, well, that basically means t equals 0. And so y equals 0 is, and at t equals 0, y equals 125. So we know that this is the point 0, 125. Of course, think of it like a Cartesian plane. If that's 0, 125, then the origin is 125 below. So over here is the origin, which means the origin is at point B. Of course, if you think about it, if that's point B is 0, 0, then point T will be 0, 125. This point on the tower, which we might call, well, I said second tower, so let's call that A. This will be 20 root 5, 0. The projectile must be passing through a point above that, so it must be passing at 20 root 5, and then that's across. Going up, it's got the tower length of 100 plus c. And this point on the top of the tower must be 20 root 5 and 100. And this point must be at some unknown range and 0. So that gives you an idea of the setup of this question. Now you want to show that v equals 100 over square root 25 minus c. Well, we'll use the fact that it must go through this point, 20 root 5 and 100 plus c. So let's do that now. So we are told in this question that x equals vt and y equals negative 5t squared plus 125. But we have the idea, based on where the origin is, that it must pass through 20 root 5 and 100 plus c. So if x equals 20 root 5, then that means 20 root 5 equals v times t. So t must equal, the time must equal 20 root 5 over v when it passes above the building. We'll sub that time into y. So y, of course, sub t equals 20 root 5 over v, as well as y equals 100 plus c. We'll get 100 plus c equals negative 5 times t squared, which is going to be 400 times 5 over v squared, plus 125. So moving that to the other side, you will get 5 times 2000 over v squared must equal 25 minus c. So square rooting both sides will give you 100 over v equals the square root of 25 minus c. v over 100 equals 1 over 25 minus c square root, meaning, of course, v equals 100 over the square root of 25 minus c, as required. So we've now used that information to calculate our v. The next question, as it says, is prove that the minimum initial speed of the projectile is 20. Well, think about what we've just worked out. We've worked out that the v is 100 over the square root of 25 minus c. And this means that the projectile clears the second building at c units above. So if you go slower, you can probably see that as you go slower, you're just going to drop faster. You won't go across as quickly. And that means you're going to clear it with less clearance. So the minimum velocity, but still clear the second building, essentially occurs when you just clear the second building, which basically means we let c equals to 0. Of course, that means v equals 100 over the square root of 25 minus 0, which is 100 over 5, which is just 20 meters per second. And that's really what they're asking for there. So now, hence, find how far past the 100-meter tower will the projectile strike the ground. Okay. So knowing that v is equal to 100 over the square root of 25 minus c, and we understand, of course, that it will strike the ground at some r0. And your equations are x equals vt and y equals negative 5t squared plus 125. So typically, how do we find range? We let y equal 0, solve for t. So that means, of course, negative 5t squared plus 125 equals 0, meaning t squared equals 25, which means t must equal 5, negative 5 projected, 4t positive. So we now know that it takes the projectile 5 seconds to land, but then we just sub that t equals 5 into x equals vt, which means x must equal 5 times 100 over the square root of 25 minus c, meaning it's 500 over the square root of 25 minus c, and therefore r must equal 500 over the square root of 25 minus c. Now, you have to read the question carefully. The question says, how far past the 100-meter tower will the projectile strike the ground? So you know that this distance is 20 root 5. So we've worked out r. So they're really asking for the distance there in blue, which is very simple to work out now that you've got r and you know the distance. You just simply subtract, do a bit of subtraction, and you're done. So the distance d, shall we say? So d will basically be r minus 20 root 5, which is 500 over square root of 25 minus c, minus 20 root 5. Now, I don't think you can simplify that a whole lot. If you were to assume, and I don't think the question is very clear about this, but if you would assume that they did let it just clear the tower, then that means, of course, c is 0, as before. If c is 0, then that means it's 100 minus 20 root 5, depending on if they let c equal 0 or not. 5 says, determine the vertical component of the velocity of the projectile when it strikes the ground. So this is actually a pretty simple question, but it relies on you knowing how to do the question, which many people forget how to do vertical components of velocity. So remember y equals negative 5t squared plus 125, and we know it strikes the ground at t equals 5. Don't forget that this is displacement. It's the vertical displacement. So to get velocity, It's just the derivative. So that's just going to be negative 10t, okay? Because the derivative of t squared is 2t, so it's negative 10t. Derivative of 125 is 0. So this is the velocity at time t. But we know the time. So at t equals 5, which is when it strikes the ground, then y dot, which is the vertical velocity, equals negative 10 times 5, so it's negative 50 meters per second. And that is the vertical component of the velocity, which is the answer to the question. If you wanted to work out the total velocity, then you basically do the same thing. You'd get the horizontal, which you already have worked out is v, capital V, and combine it with the vertical using your vector addition. But basically, that's how you deal with velocities of projectiles in midair or at any time during flight. And that's how you do the question.